All right. Good morning, Miami. My name is Mark Erikson, and today I am very excited to share with you a guide to React compiler rendering. A couple quick things about myself. I am a senior time travel engineer at Replay, where we give both humans and agents the ability to do time travel debugging. I will answer questions pretty much anywhere there is a text box on the internet. I help moderate the React community. I collect all kinds of interesting links. I write extremely long blog posts, and I am a Redux maintainer, but most people know me as that guy with the Simpsons avatar. So why are we talking about React rendering today? React's been out for, 13, 14 years at this point? I am a very firm believer that you still need to understand the fundamentals in order to use tools correctly, and that's even more true in an age of AI. And there's a lot of core aspects of React's behavior that people still misunderstand. And the React compiler actually flips some of React's defaults upside down, which means we actually need to know what the default behavior is in the first place. And really, all of this is science. It's not magic. So for today, we're going to review some of the fundamentals of React behavior. Some of this is probably going to be old news. A couple bits of it might be new to you folks. We're going to look at some ways that we can optimize React performance. We're going to talk about what the compiler actually does to your components and what is the output. And then we'll talk about how this actually changes our mental model for using React. I am known for having a lot of text on my slides. If you'd like to follow along, they're already up on my blog, blog.isquaredsoftware.com. Also, feel free to come ask me questions later. Real fast, how many of you have actually used the React compiler in any of your projects? I see a handful of hands. Also, the lights are very bright, so a few folks, not too many. All right, so going all the way back to the beginning, what is rendering? Rendering is the process of React asking your components, what do you want your portion of the UI to look like now based on the current props and state? So in our components, we write this JSX angle bracket syntax that we all know and love. And at build time, that gets converted into calls to create element, or the newer equivalents. And so at runtime, React calls create element, and it just converts that into an object that looks like the type, the props, and the children. And the same is true for both your components and the host elements that are built in, like divs and spans. So when React renders, it starts at the top of the component tree, it works its way all the way down, and then it's going to diff the element objects from the last time against the element objects this time. If you've ever heard the phrase virtual DOM, that's what this is referring to. Now, one very important point, and this is one of the biggest misunderstandings that I still see today, is that React's default behavior is when it starts rendering, it will keep recursing all the way down. So if one component renders, React is just going to keep rendering all of the children inside of that. So in this example, if the app component renders, React will by default render all 4 of these other children inside. If the inspiration component renders, React renders both of its children. React just keeps on going all the way down by default. Now, when we render, it doesn't automatically mean that we also update the DOM. React initially pitched the idea of rendering as imagine that we're redrawing the whole screen every time. But in reality, we only have to update the DOM if the components ask for something different than they asked for the last time. But in order to find that out, React does have to render the components, ask what they want now, and see if it's something different. So that means that it's possible to render a component, and it asks for the exact same equivalent children as it did last time. And if it did that, that actually kind of means it's wasted effort. It's like, well, we didn't change what we're looking for. We probably could have just skipped this process in the first place. And that's especially true if the props and the state that went in are the same. But really, rendering is not a bad thing. This is literally how React does its updates. It has to render to figure out what's actually needed. React has a number of rules. You might have heard of some of these. You're not supposed to mutate props. You're not supposed to use random values in rendering. Technically, something like a console log is a side effect, but it's not something that's going to hurt things. There's some weirder cases like lazily initializing refs. You're really not supposed to kick off a network request, but apparently it's fine if it's suspense related. Yeah, there's some weird cases there. So how do we optimize rendering components? The main way we do this is by skipping rendering a component if the props haven't changed. And React's built-in way to do this is react.memo. If you've ever heard the phrase higher order component, it's just a fancy way of saying I put a wrapper component around the one that I actually care about. So react.memo is a built-in component that just automatically checks to see if, has props.a changed from last props.a? Has props.b changed from last props.b? Or we call this a shallow equality check. The objects may be different, but are the fields inside the same? So you can memoize your components. React automatically does the checks. And if none of the props have changed, then it just bails out and skips that component. But that also means it will end up skipping everything that was inside of that component as well. Now, there is a little known trick that very few people know about. There's another way to do this process. If a component returns the exact same element object reference, so triple equals identical to the last time, then React will also bail out of rendering that child component. And there's a couple ways we can do this. If we actually wrap some of the JSX in use memo, then when the inputs haven't changed, we still have the same element reference. Or the one you might be familiar with is the children prop. If I have some state in this component and I re-render, and we use children in the output, then we still have the same literal children element reference as last time, and React gets there and sees it and says, oh, I don't have to keep going. So this has been built into React from the beginning. You might have used some of this with like a context parent component or something. React Redux has relied on this from the very start. But very few people actually know that this is part of React's built-in behavior. So I like to think of this as react.memo is the child component itself, or the definition, saying that I care about being optimized. I only want to re-render if my props change. And then the same element trick is it's controlled by the parent. Like I can choose to wrap some content in use memo and optimize that, even if the component itself isn't wrapped in react.memo. So the other common misunderstanding that I see is a lot of people still think that my child component only renders with its props change. React does not care whether the props change or not. React just keeps going all the way down. And in fact, the only time the props matter is if you're trying to optimize with react.memo. Otherwise, you could pass in the exact same props. It happily re-renders. The output's the same. React says, OK, fine. I guess I didn't need to do that anyway, but I just did. So I've heard so many times over the years, like, why doesn't React just memoize everything by default? Why isn't this built in? Should we wrap all our components in React? Should we wrap everything and use callback? And historically, the React team's advice has been, don't do this. It's a lot of effort. There are times when a component always gets new props anyway. And that means you're wasting time doing comparisons that will always return false. It's wasted effort. Plus, like you're having to stick all these use memos, use callbacks, react.memos everywhere. It's a lot of work for you. It probably isn't going to save that much performance. Just look for the places that are actually slow and optimize those. Well, guess what React compiler actually does for you? Straight from the docs, React compiler's job is to automatically optimize your entire application at build time. And the React team points out that this not only improves performance, it also frees your mind of having to actually think about doing all this work. So what does it actually do for you? The React compiler looks at your actual source code in the component, and it looks at all the props and the state and the variables that you have calculated, and then it looks at the output. It looks at the JSX and the derived values, and it traces the dependencies to figure out which pieces of output depend on which values. And then it actually rewrites the logic in your component to memoize each section based on the inputs. So what does this look like in practice? Here we have a very simple user card component. We've got a user coming in and an onFollow handler. We format the name. We have a click function. This is all very, very typical. So what does this look like when we run it through the compile? Oh no. What is going on here? Why are all these dollar signs in my Did someone spill some jQuery in here? And I have seen people kind of freak out when they see the output of the compiler. And OK, fine, it looks ugly, it's a lot longer, it looks complicated. It's actually pretty simple and straightforward. So let's break this down. Let's look at a couple example snippets from this component. Like, it sounds scary, it's actually not. If you look at the output, the compiler actually follows a very consistent pattern. For every bit of the output, it's going to rewrite it as a pretty simple if-else statement. It's going to look at the inputs. It's going to see, did any of the inputs change from the last time based on a cache? If they changed, let's recalculate the result. Otherwise, let's just use the result from last time. So here's one of the snippets from that component. I've rewritten the variable names to make this a little bit easier to read. So we have some result for the name. We look in the cache to see if the first name or last name fields changed. If they changed at all, then sure, let's call the format name function, get a new result from that, and then we're going to save all three values. We save the two inputs and the output, and we use that. But if none of the inputs changed, then we can just reuse the result from last time. This is very standard memoization. And in fact, this is the exact same thing that the use memo hook does. This is the exact same result and behavior, just with different syntax. Same idea for the JSX elements. In this case, this header depends on the name field. So we'll check the input for name. If it changed, we recalculate the JSX element, save the input and the output. Otherwise, we just reuse the last value. Exact same behavior as the use memo hook. So instead of actually having an object named cache or looking up fields like name result, the compiler just uses an array named $sign. OK. Sure. I mean, it's the same reason why jQuery ended up using the $sign in the first place. It's a valid JavaScript identifier. It's one character. That means it's shorter. The compiler is inserting a lot of extra code anyway, but at least let's try to make that code kind of shorter. So instead of saying cache bracket first name and cache bracket last name, it says $sign bracket 0 and $sign bracket 1. It's the same thing. Although, where is this $sign array coming from in the first? It's coming from something called _C? OK. What is that? So React 19 ships a new hook that's built in. I think technically the formal name for this is something like use memo cache. They actually have a polyfill for it that works with React 17 and 18 as well. And if you look at the implementation, all it's actually doing is use memoing a new array. And so what the compiler does is it pre-calculates how many things do I have to store for this one component. I need to store 11 things? OK, let's make a new array of size 11. And that's it. So it looks scary. All it's doing is saying, make me an array so that I can hold the results of all the values that I have to save for next time. So The final output of the component follows the same pattern. When we assemble the final JSX structure, it just looks at all the different pieces that it calculated already, sees if any of those have changed, saves the results, otherwise it reuses the cache value, and then we return the final result. So every single bit of data gets calculated the same way. Check the inputs, did any change? If not, reuse the result all the way down the line. Conceptually, this is just use memo, use memo, use memo, use memo, all the way down the line. So how does this actually help improve the performance of our application? One is that let's pretend that format name function is really expensive and takes a long time to run. We would only rerun it when the inputs actually change. So that saves us a little bit of time. Strictly speaking, creating element objects every time takes a little bit of work. You're making the garbage collector do some extra work. So we're skipping some of that when we don't need to. But the bigger thing is, if we reuse a chunk of JSX, we have the same element object reference as last time, and that means that React's built-in optimization kicks in, and it will only rerun those components if the inputs actually changed. OK. So what happens if you're using context or Redux or Zoostend or some other third-party library there? It's the same thing. We have our array. We pull some values out of context. We see the same if-else comparison memoization pattern all the way down. In fact, an interesting example, here we have a Redux component with an inline selector that depends on category ID as a prop. It actually memoizes generating that selector function as well. So we only recreate the selector reference when that prop changed. That actually makes React Redux run a little bit faster as well. But it's just applying the exact same 6-line pattern all the way down. What happens if you already have use memo in your component? What happens when you do read from context? Well, if you actually try this, you'll see that the compiler will look for your use memo and use callbacks. It'll actually replace them with its own logic, if possible. Now, there is an interesting nuance with use context. If your component has a use context in there, and you put in a new value in the context provider at the top, all the components that read from that context will update, even if they only cared about 1 or 2 fields in the context value. That has always been the same about React. That's one of the reasons why context is not historically efficient for data updates. But let's say that you only need 1 or 2 fields from the context value, and something goes in that changes one of the other fields. This component reading the context will re-render, but all the children have the same props. We reuse the same elements. React skips rendering all the children. And that's always been the more expensive part, that there's no way to easily bail out and skip rendering, that when one bit of the context updates, it just ripples all the way. So this does actually significantly improve the performance of context overall. What about the rules of React? Didn't we say that it's a bad idea to mutate things, especially when you didn't create them yourself while rendering? Technically speaking, this is probably not a great idea, but the React compiler does it, so it's the React team. Sure, whatever, it's fine. OK, so what does this actually mean in terms of how we understand React? And this goes back to how I said I think it's very important to understand the fundamentals. I said earlier that one of the most common understandings is React only re-renders my children when the props change, and that's wrong. Guess what? The React compiler makes that a reality for the first time. If we're memoizing all the output of every component, and we only recalculate the elements when the pieces of data they care about change, that is actually my children only re-render when the props change. This is a complete opposite of how React has already worked, but it's based on the existing fundamentals of React's rendering behavior. So what happens to teaching React in a world where the compiler actually becomes commonly used? What happens if someone, like a junior developer comes in, they learn React on a code base where the compiler has already been enabled, nobody's writing used memos, and things just work auto-magically, and then they shift to a different code base that doesn't have the compiler enabled? If you learned on the seemingly simpler code where the magic was happening, you might assume that it always works this way. I actually have a comparison with that one, and this will shock you. Start with the fundamentals. We had the exact same issue with Redux Toolkit. Redux has always relied on immutability. You have to make immutable updates in your reducers. And we switched from handwritten spread operators and reducers early on to using the immer library for immutable updates in Redux Toolkit. And with immer, you write code that looks like it's mutating, but immer actually makes it safe, but it is kind of magic under the hood. So we have the exact same problem with Redux. My answer to this is teach the fundamental concepts first. If you look at the Redux docs, I very, very, very clearly explain repeatedly in many places, immutability is important. You have to understand this concept. You have to know what it's doing. Immer makes the magic work. The magic only works inside these functions. Please do not do this anywhere else or you will break things. So to me, the answer is do the same thing with the React compiler. Start with the fundamentals, understand how React works, then you can put the extra abstraction layer on top of this and understand that it's doing this extra work for you. So you can go try the React compiler today. It's been at 1.0, I believe, since ReactConf in the fall. The React docs have a guide on setting it up and using it. There's a live playground where you can copy-paste in code samples like the ones I showed you and see all the output and see how it actually does all the work. The compiler does rely on a Babel plugin, which unfortunately will make your build process slower. They're currently, in theory, working on a vibe-coded Rust port, which will hopefully make it faster. It assumes React 19 by default, but you can make it work with React 17 and 18 as well. All right, one more thing, sales pitch for the day job. My day job is Replay. We built a time-traveling debugger for web apps. We originally built a DevTools UI, browser DevTools with time travel enabled so that you as a person can go understand really hard bugs and what's going on in your application. We recently shipped a Replay MCP so that now your agents have the same time travel abilities as well. I have built a bunch of new time travel powered MCP tools that tell your agent how many times did React render, how long did it take, a whole bunch of performance insights even from production React builds, finding a whole bunch of errors. I've seen agents find bugs in 30 seconds. And in fact, I recently published a blog post called How Replay Fixed a Real React Internals Bug Faster Than Dan Abramov Did. One, it's true. Two, I actually asked him if it was OK to mention him in that blog post. It's on the Replay blog, blog.replay.io. Please go check that out or come ask me later. As always, I have a bunch of links to further information in the slides. There's the information. Thank you very much.